going to learn about parametric equations, which are equations where y and x are defined by a third variable and both express the coordinates of points on a graph as functions in two parameters. Normally, y is defined in terms of x, but here both y and x are defined in terms of a third variable, in this case t for time. Now, in our problem, x equals 5 sine t and y equals t squared. T is in between negative pi and pi. I've gone ahead and I have filled out all the coordinates, so all that's left to do is graph it. So x equals 0 and y equals pi squared, which here is about 10. X equals negative 5 and y equals pi squared over 2, which is about 5. Here both x and y equals 0, so we plot a point at the origin. And now we have gone to the other side where x equals 5, and again pi squared over 2 is about 5 as well. And we return to x equals 0 and y equals pi squared. So our graph is going in this direction. So we'll put arrows to make sure we know. And that's it. Just solved a parametric equation.
Okay, now we're going to find dy over dx of the parametric equations x equals t squared minus 2t and y equals t plus 1. In order to do this, we have to find the derivative of x. So that means dx over dt. With the derivative, we multiply by the coefficient, and that'll be 2, and subtract the power. So 2t, and the same thing, minus 2. For y, we're going to do the same thing. Take the derivative, which is dy over dt, equals 1. So in order to find dy over dx, we would have to put this over this. And there we have it. Okay, so dy over dx is the change in the graph, which will equal dy over dt over dx over dt. And this is the slope. So let's say t equals 3, and we're going to refer back to this dy over dx equals t. It'll be 1 over 2 times 3 minus 2. And for PEMDAS, you multiply first. So it's going to be 1 over 6 minus 2, which equals 1/4. So the slope would equal 1/4.